I'm Sheretta Thomas, and I am a PhD student in the Environmental Toxicology program at Texas Southern University. I am also a fellow in the Center for Bionanotechnology and Environmental Research, CBER for short. I have been affiliated with NASA for many years, and as a NASA fellow, NASA scholar, it dates back to undergrad when I did a small research project. Under Dr. Gigello, who was my advisor and mentor, and segue into me being a NASA Jenkins Fellow, which allowed me opportunities to collaborate with institutions like NASA Ames Research Center out at Moffett Field, California, as well as Stanford University's Genome Technology Center. And currently, of course, again, I am a CBER Fellow, so I have a long history with NASA education programs, and hopefully that'll provide me an opportunity to have a career as a NASA employee someday. And while I was at NASA Ames in Stanford doing my research, I performed experiments that were designed to detect various species of fungi that were problematic that were of concern to NASA. And they were of concern to NASA because these species of fungi had been isolated from NASA spacecrafts and on various missions in the Russian space station Mir and also in the International Space Station. So on Earth, it's very difficult to identify these fungal species of concern. So the project as a whole was designed to develop rapid approaches for identifying these fungal species, and to do so I employed various techniques. In my research, I did a lot of cloning, a lot of DNA extraction, did a little bit of fungal culturing. I employed a novel technique, or at least then it was a novel technique. It's been around for a few years now, and we've been utilizing it since. But when I started using it, it was a relatively new technique called pyrosequencing. Additionally, did some Sanger sequencing and was able to develop an approach by which we could identify these fungal species on a genomic basis, as opposed to employing those conventional techniques that have been proven to be time-consuming and laborious. Pyrosequencing is a technique that is basically a synthesis by sequencing approach. It's a short DNA sequencing approach that eliminates those time-consuming techniques that were required in order to perform Sanger sequencing. So we're actually able to get sequence data a lot quicker, which is one of the aims of the study, is to develop a rapid approach for identifying these fungal species.